Hello and welcome everyone. My name is Ravi Sharma and I'm the National Chapter's representative and board member for PanIIT USA. On behalf of PanIIT USA, it is my proud privilege to welcome you to this webinar session today. This webinar is part of the AI Frontier series. The series is designed to enrich our alumni community with cutting-edge insights into modern artificial intelligence and related fields. Now, artificial intelligence and robotics have traditionally been distinct disciplines, different fields. But that was when robotics or robotic tasks were often predictable and repetitive. Today, AI and robotics are increasingly intersecting. For example, with computer vision and NLP, robots can now be smarter as they can navigate, detect, and react. All this is made possible by machine learning, deep learning in particular, or you may say AI in general. By the way, the modern AI robotics industry is a fast-growing one. According to some estimates, the AI robotics market is expected to grow from the current projected about $17 billion this year to something like $64 billion in 2030. That translates into a CAGR of about 25%. And these estimates may be very conservative if you take into account autonomous systems, especially autonomous transportation, etc., if it does become a reality during this period. Our speaker today is Professor Dinesh Manocha. Professor Manocha is Paul Chrisman Erebe Professor in Computer Science and Electrical and Computer Engineering at University of Maryland, College Park. He's a distinguished professor, university professor. He's also a distinguished Professor Emeritus of Computer Science at the University of North Carolina, Chapel Hill. Professor Manocha's group has developed several packages in robotics and simulation that have been licensed to more than 60 commercial vendors. He has published more than 750 papers and supervised many, at least 50 PhD dissertations. Professor Manocha is an inventor and holds 17 patents, some of which are licensed to the industry. Professor Manocha is a fellow of AAAI, the Association for the Advancement of Artificial Intelligence, the AAAS, ACM, IEEE, and NAI, the National Academy of Inventors. He is also a member of the ACM SIGGRAPH, the IEEE VR Academies, and he is a recipient of the Bezier Award for Solid Modeling Association. More than a decade ago, Professor Manocha received the Distinguished Alumni Award from IIT Delhi. That was back in 2011. And he has also received the Distinguished Career in Computer Science Award from Washington Academy of Sciences. Professor Manocha was a co-founder of Impulsonic, a developer of physics-based audio simulation technologies, which was acquired by Valve Incorporated in 2016. In addition to all this, Professor Manocha is also a co-founder of Inception Robotics. There will be a live Q&A session after the talk portion of the webinar, but please feel free to post your questions in the Q&A window at any time. We may pick one or two in the middle as well. But please limit yourself to one question, if possible, so that everybody can get a chance to get their questions answered. For our alumni residing in other parts of the world, for many of whom this time may not be convenient, this session is being recorded and will be made available to them for watching later. You may go to iit.org or the PanIIT USA YouTube channel to watch the recordings of the webinars that are being organized in this series. With that, please welcome Professor Manocha. Professor Manocha, thank you so much for taking the time out of your very busy schedule and coming to talk with us today. Please proceed.
Thank you, Ravi, and good afternoon. Can you all hear me well?
Yes.
Great. Thank you for the kind introduction. Let me first start with thanking PanIIT. I've myself been involved with PanIIT for a long time, and I cannot thank what they all do for not just IIT alumni, but for the broader society. In fact, there was a wonderful PanIIT conference in Washington, D.C. area where I live in the suburb of Washington, D.C., and I'm at University of Maryland, College Park. College Park is a suburb of Washington, D.C., so it's amazing to see all the amazing stuff that PanIIT have done. So thank you for giving me this opportunity. It's 1 p.m. in Washington, D.C. area, East Coast of US, and thank you for people joining all over the place. Some of the experiences, we have been looking at robotics and AI, and this talk is also, I would say, there are a lot of excitement, but also there are a lot of challenges, and sometimes I feel that while AI robotics are very exciting, sometimes the hype exceeds the reality. So we have to be very careful and honest of where we are today and what challenges we do face. So since this is PanIIT, let me just tell you, I'm from IIT Delhi. This is my campus. And interestingly, my association in IIT Delhi started when I was 3 years old. Yeah, no, I did not go to IIT when I was 3 years old, but my father, Professor at IIT. So I grew up in IIT Delhi campus in 1968. And then I went there for my undergraduate degree, where I graduated in 1987. I was the second batch of computer science from IIT Delhi. In the 80s, computer science was a relatively new topic in IITs those days. And of course, just to let you know, my exposure to robotics actually started with my undergraduate project thesis. I had a great advisor, Professor PCV Bhatt, which my thesis was on robot motion planning. And then I went to graduate school, where again, I did robotics and geometric modeling. So this is just a brief history. I was a faculty member at Chapel Hill, where I spent 26 wonderful years. And I moved to Maryland about 6 years ago. But one of the things that I've enjoyed in my career has been that work closely with industry, especially robotics, AI, and simulation, which are very tightly coupled together. In the 90s or 2000, 20, 30 years ago, they were not so integrated. So I had fortune to work with a lot of companies and a lot of people, which have influenced my research. So I'm really grateful to all the real world interaction. And I also want to acknowledge, today we talk a lot about open source software, but that was not a common thing 30 years ago. And my research group actually had a lot of some of the initial packages for open source. 30 years ago, it was not so common, and a lot of stuff is here. But I really want to acknowledge, I've been very fortunate to have a lot of wonderful PhD students at Chapel Hill first and now at Maryland. Many of them are leaders in industry and academia. Some are doing their own startups. I currently have a very large group at University of Maryland doing a lot of AI robotics. And of course, I have hundreds of collaborators worldwide, US, India, Europe, Asia, Korea, with lots of collaboration. So I always want to acknowledge that at least I will show some of the work that is coming from a research group, but I always want to acknowledge, the people behind all the work is mostly my students. They are the one doing all the hard work. So they are the one who deserve a lot of credit if you see something wonderful. So with that, let me get into it. Robotics is a very common thing. There's always some media coverage, what robotics means or what AI means. But I would not go into the media coverage, but what we think of robotics, it's a pretty traditional field. This is something I teach in my undergraduate class. The word robot became popular in 1920s from a Czech play, but you go back more than close to 800 years, and this is some evidence from history, coming up that that how people have think. So this is just some historical preview. Somebody was serving a meal by attendance, or somebody Descartes, the famous mathematician, did some wonderful things. That was it. And there's also of historical. I'm just showing some samples which we got. This is some of them are 18th century, some are 19th century. That people try to build some machines or some kind of task automation. So the idea of automation goes back to many hundreds of years ago. It's not really totally new. But literally, when we teach in a class, there's also this by Nikola Tesla, who did a lot of wonderful things. But the term robot, at least the way we call it today, became popular in a Czech play in around 1921. And the author was Karel Čapek, if I get it right. And they had a plot that the man makes a robot, where robot kills a man. So that's not the best introduction, but that's where thing comes up. And the origin of this word comes from a Czech word robota, which really means servitude, forced labor, at least. But that's not the way. I don't want to convey that impression in my talk. But literally, this is the person credited with the term robot in 1920s. And this notion of, robot, some of us who grew up, in 80s and 90s, who watched Star Wars or Terminator or Frankenstein, at least in those movies or in those, series, you saw this kind of a science fiction version of, what robots are. But let's move ahead, In the 1940s, you see many more evidence. This is only small samples, There was a, Westinghouse, the famous company did the dog. Asimov, who wrote wonderful science fiction novels. Some of us grew up reading those, And literally, they use the word robotics in the science fiction called Liar. So that's where thing. And there's a field what we call, cybernetics. Some of you are in that area, follow cybernetics. There's a lot of journals and books on it, which was combining ideas from feedback control theory, which normally you see in engineering classes on electrical and mechanical engineering, information biology, And the idea of the field was to bring ideas from control theory, information sciences, and biology to see how can we communicate and control the machine. So these ideas, goes back to 80 years now. But really, the field we call robotics, at least the vision we have today, again, goes back to 50s, at least I wasn't born that time. And in the 50s, we saw suddenly computing technology coming up, right? After Turing invention, and 50s, we see a lot of great advancement from 50s onwards, computer and control technology. And there was this famous gentleman, George Deville, who replaced a slave manipulator in a teleoperator called CNC. This is a numerically controlled machine for manufacturing. And this is, at least historically, we believe, at least the first industrial robot. Again, 1954, we are almost 70 years behind us, right? But the main thing happened, and this is the two parts to my talk, AI, which is, the very hot thing right now, and robotics. And actually, the foundation of both the fields, whether coincidentally together or not, happened around the same time, in the mid-1950s, Some of you heard about there was a famous Dartmouth conference around 55, 56. Marvin Minsky, one of the legends and pioneers in AI, they defined the notion of intelligent machine that would build up an abstract model of the environment in which it plays, and if you're given a problem, it could explore solutions. And around the same time, people started looking into what's called perceptual. A lot of it was computer vision, which is now very common today, using computers, cameras, and also touch sensors. Because humans rely a lot not just on computer vision, audio, but also touch. The way we walk, the way we run, even the way we grab objects, cut vegetables, the way we ride, touch plays a very big role in that. So clearly, the researchers were born for that. So around 1955, 56, you can see the real excitement of what became AI and what became robotics has been going around. And these communities have been somehow overlapping or disjoint, whatever, for the last 70 years. Of course, now they've come more together, but there's a lot of overlap between AI, and robotics is a form of AI, somebody would say, but that's not really an issue here. But literally, how do you define robotics? And I look at a lot of sources, and I like this one on perplexity.ai. It's whichever web search engine you want to fool. But fine, a robot is a autonomous machine capable of sensing environment, carrying out computations to make decisions, and performing actions. So really, if you look at this definition, there are three main components we look at. You sense the environments just like humans and animals do, Mostly we use cameras, but nowadays we use microphones, speech. We have pressure sensors. You could even have outdoor robots could even have, location based on GPS. So the sensing technology, especially in the last 10 years, has really become amazing. Even if most of us carry a smartphone in our pocket, and the amount of sensing a smartphone has, your Android phone or your iPhone, is just incredible. Second part is the more mechanical part. They have actuators. And these actuators basically let you move or manipulate objects. You see robots with wheel robots, most common one. In the last few years, we're seeing like quadrupeds or even humanoids. I'll show towards the end. And of course, you have something which works like a hand. All the robots' hands are nowhere close to human hands, but you see simple grippers, or you see, other kind of thing. But behind all that stuff, I'm more of a computer science by training. I think more like a computer scientist, There's a program, just like any program that runs on your iPhone, runs on your PC, a program or AI that processes sensor data. Sensor data is going to input to the program, and that controls the commands to the actuators, which actually do the motion. So you feed the sensor data to the program does all the smartness, and now we're seeing a lot of machine learning and AI going into this program. And that program give instruction to the sensor to move the data. So this is the three parts of the robot right here. Now, literally, the first big application robots were actually in industrial application, and they have been around for more than 60 years, So one of the pioneers, Joseph Engelberger, in fact, there's a famous award in robotics named after this founder, Joseph Engelberger, literally bought to a Devils robot and found a company, one of the first industrial robotic company in the late 50s called Unimation Company. And of course, George Devil took it up and literally, called that program robot and called it Illuminate. So this is, again, you'll see robots come into the real world industry for this. And literally, from 1960s, so robots have been around in industry. We probably did not see in our daily life. We saw some in the movies or if we worked at a factory, but they were not our daily life. But the notion of robots being industry goes back to 1960s. And this is from Robot Institute of America in 1979, they say industrial robot is a reprogrammable multifunction manipulator designed to move materials, parts, tools, or special devices through various program motions. So this notion of the three definition I gave you, it has a manipulator mostly designed to move materials, parts, and through variable program. Now, some of the initial robot that we built were like fixed function. They were like, I give you an analogy of you record some music in your device, IP3, you record, let's say 20 songs, and you play those songs, in certain order. It just repeats that song is being played, There's not too much intelligence in that. So the earlier robots were literally manually programmed or like customized human-centered program to perform a variety of fixed tasks and at a particular location. Of course, now this is 2024, and things have advanced quite a way, and I'll show example at the end where we are. But literally, this is like, a lot of, in the 70s and 80s onwards, even when I took the first robotics class in 80s, we would see examples like this in the books 40 years ago, that here are some robots, the company KUKA, I work with them quite a bit. And you can see they're doing some welding tasks or, painting tasks, of this very heavy machinery task or some dangerous tasks to do it. So there's a one video I'll play, and these are the videos you'll see all the time. You can find tons of them on YouTube, of robots being used in industry. So this is a little bit like a, dangerous task, a little bit of welding, so robots could do that. And this is one of the company called ABB shown here, right? So these kind of applications have been around for, more than 30, 40 years. So that's really not new. Robots in manufacturing is an old idea. Now, what happened is around 2000s, when computer science was taking off, and as I said, there's a big move toward people releasing software, and especially open source. Now, nowadays it's very common. Everybody, we publish so much work on GitHub, especially in AI, machine learning, and even language model coming open source. But it wasn't the trend, as I said, one of my own research group released one of the first package for collision and planning in 1995. And this is a time when web was just coming up, and there was really no Google that time, there was no web search. So we used to just send out email lists and tell everybody in the world, about 200 people, hey, we have a package, or we go to a conference and talk about it. But now, today you can search on, any of your Bing and Google, you can find so much software. But one thing that happened a lot, that a whole bunch of community came together and built a package called ROS. It's still being evolved. Now there's ROS 2 or ROS 3. which stands for Robot Operating Systems, is literally open source framework for building robotic applications. So this advancement by a large community of people from academia and industry, literally, which started in 2000, has played a very big role, in development of new technologies, especially now as dissemination is happening. So this is just an older video I'll show you, 15 years old. In ROS, you can actually do all the simulation of different gripper tasks, So you can really do the simulation of a manipulator. Any manufacturer, of a robot will release their specs. You can import them in ROS. And before you go and try it on a real hardware, on real manipulator, you could go and literally simulate that, can the robot do this task? And you can also do a lot of manipulation. So this was a big thing. There's also ROS Industrial this has been around for about 15 years, and you see huge deployment, or ROS-like ideas. This is it. As I said, this was original ROS, this ROS, the ROS 3 open source doing it. Now, my own group, there's one part where I work on a lot of planning and things. There was a company in early 2010s, Willow Garage, right next to Menlo Park in the Bay Area, and they did a lot of wonderful work and releasing packages for ROS. It was open source, So this is just to show that you want to plan the robot, and this is around 2011 that this was a robot called PR2. We have a similar for that in ROS, you can see. And this robot has a sensor, like a LiDAR or some cameras. And this is technology of 2011, where it's capturing a point cloud. The technology you have today, even your smartphone, is much, much better. But this is just to show you the earlier days that how you have the sensors with a LiDAR and a camera is detecting the obstacles and trying to go and grab a Coke can, that you saw the can there. So this is bringing some more programmability to the robot, that it can do some reasoning about the environment, which was traditionally not the case in industrial robot. Industrial robots did not have this capability, but this was some of the earliest cases of computer vision and sensing and programmability coming to robot. It can do tasks. So this is where, things were really taking along. So this is around the time, I would say, 2010, 2011. That's the time when, if you look at the history of machine learning and neural networks, although the ideas of neural networks and machine learning backpropagation are very old, but the first successes you saw around 2012 in computer vision and speech came around the same time, and a lot of things happened. So just around the time machine learning was taking off, speech processing and computer vision was taking off, there's a huge community of researchers worldwide started saying, hey, this is the form of robotics since 1960s. You see these robots used in manufacturing and heavy manipulators doing amazing tasks. But can we now bring all that knowledge, programmability, which is happening from computer science, from what we call special purpose autonomy? Like if you look at the early robots were custom built for certain tasks, painting tasks, manipulation tasks. They were programmed by human experts or special behaviors, very challenging. To what we've been pursuing for the last 12 years, can we build general purpose robot autonomy? So this is, inspired by how humans or animals do. Animals are biological creatures who can go to any environment, adapt themselves. So now, with all the advancement in programmability, with computer vision, machine learning around the last 10, 15 years, the same thing has happened. So this is what, you might say, this idea is not really new, because people who were in the 50s and 1960s were doing AI-driven robotics. But as I said, machine learning and computer vision are not new fields. They've been around from 1950s. But thanks to the popularity of machine learning and other big data, they've literally got a huge jump start in 2011, 2012. And that led to the whole community of, robots too. Can we do it? So this is what I'll talk about today, where we are with AI-driven robotics, and this is 2024. And as I speak, I was just at a conference last week. There's the biggest conference I would feel called ICRA, IEEE International Conference on Robotic Automation. It had the biggest possible gathering of 6,000 people, and it was just the amount of buzz and amount of excitement we saw in the conference, and this is called generative AI and robotics. It's incredible. I've never seen so much excitement in in 35 years of my life, but certainly we are really enjoying all the excitement of the research in this. But let me just tell you, this is the classical robotics pipeline. As I told you, there are three parts to it. A robot is a sensing module, primarily computer vision sensors, depth cameras, LiDARs, IMUs, all kind of stuff, pressure sensors, audio sensors. This is the part where the planning comes in, right? The brain of the robot with some kind of program, and now a lot of this is using machine learning. And then once you do the planning, you do the command. And it's very similar to human system. Human system, we got five senses: eyes, ears, touch. We also got smell and taste. Our brain is processing. We still don't understand how the brain works. We're trying to emulate that, understand it. And then, you send your muscles, bones, all this happening real time. So this planning pipeline is what robotics have been doing for a long time. And now what has happened last 10, 15 years that these machine learning methods literally penetrated all these things. So traditionally, there were different communities in the academic. This was computer vision community. This was robotics and planning community. This was control community. And now, you go to any conference, you go to any meeting, you see a lot of papers, a lot of academics, a lot of industry people using machine learning. So now, in the last 10 years, this machine learning penetration has gone through, and all these fields are seeing a huge insurgence. So, I try to see how do we define AI-driven robotics or robot learning. There's a whole field called robot learning. There's a conference robot learning. And here are the three definitions I just got from the web, It's applying machine learning algorithm and principles to robotics problem. A lot of machine learning we're seeing is based on large data, as you may have heard about that. And what Wikipedia says, it's a field at the intersection of machine learning and robotics. So these are all different ways of saying the same thing, what's going on. But literally, why do you want to do it? So this is a slide I got from a colleague at UT Austin, Why do we need these capabilities? Because robotics has been around for 60 years before that, right? But we saw those usage in factories. They were very controlled settings, Factories were designed with no clutter, no people for those manipulation of welding tasks. But the physical world that we live in, and I'll come back to the challenge of physical world. Think of a home. Think of your office, right? Professors always have messy offices, or think of anywhere outside, right? Real world is too complex, right? So we want to deal with object variation. And obviously in computer vision becoming so good, we do that. What are the challenges we deal with human uncertainty? I'll tell you about some of the work we're doing. Robots in very crowded scenarios, robot in very crowded traffic, right? Most of us, it's a Memorial Day weekend in US, we may go to the mall, you're going to see a big turnout of people, right? Or you go to travel traffic. And just the people around us, in fact, ultimately, if robots have to really take on, robots have to live in our physical world. That means in our homes, in our offices, in our airports, in our metro stations, or our streets. And literally, just like humans adapt to the physical world, robots need to adapt to the physical world. So now there's a whole community of thousands of researchers saying, can we take advanced machine learning to deal with these problems? So this is an exciting area to be in. And this is, why machine learning came up in 2010, 2012. A lot of things happened at the same time. As I said, a lot of deep neural networks idea was not new. They've been around for many time. But this is the same time computing power came up, especially GPU power. And, look at GPU power. The leader is, I was working in GPU computing. My own group was doing GPU computing in around 1999. We wrote the first paper in 1999. And we published a lot of papers from 1999 to 2010. We never thought of machine learning. We were thinking about databases, geometry, or high-performance scientific computing. But when people found out that this neural network inferencing in the hardware, and today, if you look at it, you just look at NVIDIA, right? They just came with the earning 2-3 days ago, and look at the penetration they have, right? It's one of the biggest expensive companies. It's GPU power. So three things have come together, basically the AI, which is driven by data, computing power, and also I would like to show you, especially towards the end, we are also suddenly seeing some amazing robotic hardware. My talk is going to conclude with one humanoid robot, which was just introduced about 10 days ago. You'll see this is coming up. So this is this combination of programmability, with AI, all the data and all the machine learning methods and computer vision and the hardware. Suddenly, this combination of these three things is really fueling this field. And that is the excitement that I saw last week at the biggest conference. Oh my God, we are at a cusp of a big thing. I've never been so excited about robotics in my life, in spite of all the challenges that it is today. So I will not talk a lot about computer vision, if some of you have seen this talk. So if you take a course on computer vision, some schools offer a senior level course or a graduate level course, you will get exposed to all these things. This is not a talk on computer vision 101. You learn about object detection, visual learning, data processing, attention. So these are typical topics you will learn in a first course on computer vision. But of all the amazing computer vision, the biggest conference in computer vision is academic conference, CVPR. Last year it was in Vancouver. There were about 10,000 people, and there's one in about 3 weeks in Seattle, 3-4 weeks in Seattle. These conferences are exploding. This conference 10 years ago barely had 1,200 people. Now there are 10,000 people, and just so much excitement. But at the same time, in the robotic learning, when I teach a robotics course, then you'll see these terms coming up. Some of you heard about reinforcement learning, deep learning, supervised learning, imitation learning. If you take any first course on machine learning, you will learn this concept. And again, my talk is not going to give you an introduction to machine learning today, but all these concepts that you're learning in machine learning, there's a whole community of researchers in academia and industry basically applying this concept. There's so many startup companies right now building the ideas and building commercial products. So this is what literally this advancement in computer vision and learning is lit with the hardware is amazingly doing things. So my goal is today not to talk so much about the basics of machine learning or basics of computer vision. They have come a long way and they'll continue to advance. So anything that makes computer vision better, anything that makes machine learning better, clearly benefits robotics, But I want to also convey robotics is more than just computer vision and machine learning. And there are more challenges that won't do it. But if you look at the last 10, 15 years, what have we seen in robots? So if any of you order a package, let's say from Amazon, right, which is one of the biggest online shopper, right, there's a very likelihood this material, the packages are in a warehouse somewhere. By the time that they take warehouse, they ship it and deliver to your home, leave it outside your door or your wherever it is, some robotic thing is involved. So one of the big success story happened was Amazon warehouses, that they are all about scale. And they use a lot of robots. This fun video they showed you.
Since rolling out the Kiva robot across its fulfillment centers, by 2018 they had 100,000 of them. By now that figure has comfortably surpassed 200,000. Amazon Robotics has been refining the design still further. The new iteration of Kiva, known as Pegasus, is 10 centimeters shorter, meaning more can be stocked on top and uses half the parts, so it's cheaper to manufacture and maintain. Amazon says Pegasus can lift a hefty 600 kilograms and can be customized with a conveyor belt to work in the sortation centers.
So warehouses, these are large warehouses. Some of them are like 400 meters by 400 meters or even bigger than that. But Amazon claim they sell close to 1 million items. You can go to the website. And from last I heard, and I've close side with Amazon, and a lot of my friends and students are working there, they're deploying more than 700,000 robots in their warehouses. And it's just going up. I've seen the kind of robot they're building in different warehouses. Amazon all about scale. How many items they ship, especially when the Christmas shopping season comes in the United States or the Western world, the number of orders go up. And they say they cannot reach a scale without robot. So this is a case where we need robot capability. You're also seeing in other company, Berkshire Grey, more and more factory industrial automation happening.
Advantage.
So
since rolling out the Kiva robot across.
So besides traditional automation, you'll see much and more sophisticated job, more functionality coming up. A lot of sorting packages, picking them up, shipping them, right? So they are deploying these robots at a huge scale. In fact, the current perception is right now, we are at an amazing time with a lot of hardware, generative AI. And the prediction is you will see more and more industrial jobs being automated robot. That's what I personally see the biggest thing. But while I talk about warehouses, I also want to bring up, there's a very good company, there's a good friend of mine at Verb. They have a big office outside Noida, in the suburb of Delhi, which is becoming one of the biggest players. So this is my good friend Sangeet. He gave me these videos, and I really love what they're doing. So they are, of course, Amazon developed amazing robotics technology, but Amazon technology is all for internal consumption. I don't think at the moment it's available to outside people, but there are a lot of big players who are providing solutions for warehouse automation. So at Verb being a major player, I've been actually following them very closely for the last 5 years, and I'm also with their setup. You can find the videos on YouTube. So this is how they're lifting. But this is an example of how they took a DHL and literally automated it.
Today's world is being revolutionized by technology, and warehousing automation is no exception. In partnership with DHL Supply Chain, a global leader in the logistics industry, Adverb implemented an AI-enabled sorting solution utilizing Adverb's conveyance for inline scanning and weighing, our proprietary enterprise-level software for real-time system and carton monitoring. In 20...
So you'll see this huge amount of industry, huge amount of money.
Specs, what that end customer gets as far as being the team member. They'll scan a carton, it immediately tells them where to place it, and instead of carrying it for 50 plus yards like they might do in the old system, literally they turn, they pivot, they place the carton in less than a 3-foot radius, depending where they're at in their assignment grid.
So warehouse already has seen a big impact on robotics, and again, there are a lot of things to be automated in warehouse, but this industry is taking, there are a lot of players in this area. So warehouse automation is going to happen. You'll see a bigger chunk of automation, this thing. One thing that Amazon tried to do, which they have limited success, when they take your item and ship them in a box, they support a picking challenge. So picking is still not quite there, but again, a huge community is happening there. Now, while these warehouses are great, most of us, we just order stuff online. We don't deal with warehouses, right? We just want shipped to our home. So literally, this is at a time when we also see all other kinds of robots, right? So there's a lot of interest in humanoid. Tesla introduced some. There's a lot of interest in this quadrupeds, which is I'm also using this. They're small robot, like people building robot of the size of a fly. And there are a lot of medical procedure, laparoscopic, where robotic again has a huge impact. Or the snake robot, which come up in search and rescue. So these are a lot of exciting robots. But what happens is, if you look at the biggest deployment of robots, at least in the real world, is still in the cases which are robot friendly. Like warehouses are designed to be robot friendly. They put sensors on the ground. They put these markers. Even Amazon, they have some robot with no sensing. When humans enter, they put a special jacket so they can detect them. So warehouse can be designed to be robot friendly, but you come to my home or my office, as I say, my office is always messy. So robots have to adapt to me as opposed to me adapting to the robot. That's what the situation is. So one of the things which is you see a lot of nowadays, you see more and more videos. How do you see robots? At least I've seen many restaurants where robot bring a food to you. Now restaurants are more specialized. They can put some sensors you don't realize. And here's a robot coming up there. There are places robots are serving food. This is George Mason campus. It's also the suburb of DC. There are examples of, robot sitting in your dorm room and bringing you food in the morning, right? The robots used here on the right. You see some videos like this, robots entering a dangerous place with a radioactive material or some kind of thing. But a lot of these mobile robots you see, I would say these robots have limited functionality. There's also, of course, a planned robot. They're not fully autonomous. Either they're in a very restricted setting or they're teleoperated by the home. And there's an example of this robot from these people, right? From Amazon, they call Astro. I'll show more examples of that, where it's used for like guarding your businesses. It's kind of monitoring your place with a ring system. So in the last 5 years, we have seen lots of such examples of mobile robots in the restaurants, on your campuses, in a dangerous outside places of surveillance coming up. And this is where a lot of investment is going around, where people are trying to make this robot smart and autonomous. And my own group is doing a lot of work in that. So one problem I'll show you some of the work, and maybe I'm showing it probably because I'm biased, because my group has a collaboration with them. This is Lab 126 at Amazon. About 1.5 to 2 years ago, they introduced a robot called Astro. You can actually go on the online and order it, maybe back order. But they introduced a home consumer robot. See what this looks like.
A robot.
Yes.
What are we going to do with a robot?
Well, Astro, follow me.
Hi, Grandma. I miss you.
I miss you too. Hey, you got the toy I sent.
Yeah, I love it. Astro, follow me.
Cool. All right, race ya.
Come on.
Told you I turned it off.
And now I totally believe you. Ooh, yikes.
Message from Steve. Remember to eat something green today, Dad.
So this is, I would say, one of the most challenging projects. They're trying to sell a home robot which will work in everybody's home for less than $1,500. Of course, this robot doesn't have hands. It can monitor you, control with an app. But it's really also, there's so many challenges in making it work because you got limited sensing, you keep the cost down. But also, as I told you, robots are something that runs your AI programs. A lot of AI runs on the cloud, but they are running AI on edge computing. This small robot cannot have a big GPU like a H100 from NVIDIA. So that gives rise to all kind of challenges, and we have been working on them, right? And you see there are a lot of, this promotion on the video you can find. People, the consumer product, they review it, and they say it works well, but people report the case it doesn't work well, right? So in your home, you come with a situation you can't predict, right? This is like a thing where robot came and got stuck. In this case, somebody had a lighting condition with a mirror or glass. The robot comes up. So this is the challenge that comes up with robotics, right? The physical world that we live in is just too many challenges. And this is a problem that is hitting robotics is very hard. In computer vision or machine learning terminology, we call there are too many special cases or a long tail. And how do we develop robotic technology? This is like when shades come up, when lighting comes up, we got this, So they have to do certain thing in your home to make it robot friendly. So we are still not totally there with 100% robot. And some of the work we have done, which I will not talk about it, but one of my students sent work with them, interned there twice, literally, to develop better AI technology we call navigation technology, so that, so the robot can really work in different situations. So this is still, one thing that the robotics community and the AI community is dealing with is that these too many special cases come up in the physical world, or we call the problem a long tail. And that's where we have challenges with machine learning because we don't have enough data to train them. So this is one example, a lot of time this comes up with Astro Robot. It comes with a situation you're not familiar with. And just to be safe, it'll freeze itself. Like, I won't move. You heard the same story, like cruise cars were doing autonomous driving, they'll freeze itself. That's what happens there. So the Amazon also did another project, which actually they called off. And from Amazon, you don't know how much money they spend on delivery. Even in US, I heard many years ago, their delivery budget is about $25 to $30 billion, even more. I don't know the number. And they say, can a robot come and deliver your packages? So they did this project, ambitious project, but then they actually, a year and a half ago, they called it off. So this is, they tried to get robot deliveries. It's an economic sense, but guess what? They found that robot technology is not there. Most of us don't have this client speeds. So I'll tell you some of the work I've been doing, a lot of collaborators in Asia, you'll see, how can robots work in our daily life? As I told you, not just your home, your offices, your shopping malls, your streets. These are the places where most of us walk, right? And the real world is not as nice and clean as you see on the lab. Real world is more challenging. So this is where some challenges comes up. When can robots work seamlessly in our daily life? We're still not there yet, and I want to be clear about that. So this is some of the work my own group is doing, both indoor and outdoor scenes, and we have made advancement, but we're not 100% there yet. So here example, when you put a robot, sometimes you bring robots when people look at them, actually they act funny. Sometimes I joke, people become mean to robot. They want to go and do funny things to it. Now, this is our building. Our building at Maryland is a wonderful computer science building full of glass. I love the glass field, but having this glass creates problem because the sensor on the robot, cameras and lidars struggle with it. And this is just outside when you have like beautiful vegetation. Here's a robot which costs $120,000, spot Boston Dynamics, tumbles over. So, see, real world is not that friendly. You saw that warehouses, and these are challenges we're dealing with it. So some of the work we're doing here is, this is just a just show a sample of work. We bring all this computer vision and deep reinforcement learning, see what we can do this with. This is the work of some of my PhD students, and we tested this. This is one of our computer science building, where we put this robot with a GPU on the laptop and sensor, and we showed, can the robot go in a totally mapless crowded scene? And you see, this is a lobby. Robot is, of course, smaller, 2 feet tall, but you see what people are doing to it, and robot has to deal with it. Because in real world, as I said, you don't know what people will do to you. So humans know how to work around this situation, but now we're dealing with robots which can do with this what we call dense crowds, because what is dense can depend on how people move. Let's say you're in a metro station, like go to a metro station in Delhi in the morning, it's so crowded. How robots can look at how humans are moving, and the burden of proof on the robot should not run into people and do this kind of thing. So this is the kind of challenges we're dealing with our own group and lab. Now, this is something, a couple of my students have this conception about it. They have little robots like this. This is autonomous, sensors, and totally somebody out of the building, robot will deliver them. We also deployed testing for the big event. This was right after COVID. This is a robot walking around, checking people who don't have their masks.
What's up? I'm taking a video.
Taking water. And the robot works as a bartender. It doesn't have the hands right now. The basket will be thinking. So, other thing that we tried when COVID was going around, right? This was a couple of years ago. My students built this robot called COVID monitoring robot, where basically robot is monitoring around, telling people you're not maintaining social distance, or you're not following safety precaution. So this is hopefully a positive case where robot is listening. Imagine robot being in a metro station or warning people about, hey, follow the precautions. So you can imagine, robot being a monitoring station. This work got a lot of media coverage because this was the peak of COVID, later on. And people are looking all kind of solutions. But you can think of robot model of privacy concerns having some sensors. And here some people not maintaining a robot come as a warning sign to you and tell you basically, go get it right. So this is mostly indoor scene. One thing we are working on is, I say, outdoor scenes. On outdoor world, imagine you want to go hiking or you walk on a street or yard, right? And these are not just for robot hiking. This is for your lawnmower, agriculture robots. Can robots navigate the physical outdoor world? Because outdoor friendly is all kind of bushes and things. And if you look at current robots, you have all these problems like this.
This is grasp.
You go here, robot gets, collided, all kind of vegetation comes up, it gets problem, or you get freezing behavior. Exactly. This is just on our campus, Spot robot, very expensive hardware, and we don't want it to get stuck, or even sometimes these tall weeds or grass or this thing get entrapped in your joints, and you see what will happen to robot in a couple of seconds. It just gets joined. This is. So how can we develop robot technology which can deal with all those things? So this is something we have been working quite a bit about, how do we bring machine learning and dynamics and a lot of vegetation dealing. This is it. So just to show you, this is work, a couple of work we have done. This is on the left. If you buy a Spot or even a Ghost robot, they build an autonomy, but that's not as good. And here we are dealing with, you see a lot of sensors on the robot and all the GPUs to do the program. They traverse the terrain they figure out what is walkable, what to avoid, and they go through it. As I said, a lot of time it's not your clean sidewalk. You just have to avoid people. Some of us have to walk in this area, and the robot technology is in that direction too. This is some of the work we have done, where basically told us somebody, can robot go through very dense vegetation? It's like this grass is about, you may not see the scale, is 4.5 feet tall. Now, most of the time you say it's too dense, don't do it. But sometimes there are situations one has to go through vegetation. So you can see, we put this flag because we were just worried the robot may just get lost in the grass, we cannot see it. And you can see the robot dealing with very tall grass, and it's all autonomous, figuring it out, how to go around it. And there could be like a fallen tree and all that stuff. So this is what I call robots operating in a challenging and unfriendly real world. Now, when I talk about robotics, in the last 10, 15 years, if you look at the amount of excitement, the amount of media coverage, and the amount of money has gone, is autonomous driving. This has been around for last 15 years. Every car company and most computer companies like Waymo, Amazon, right? And earlier even Apple were working on this. So you see a lot of things, and many of I myself been following autonomous driving very closely. At one time, 10 of my students working autonomous driving, doing very well. I've been taking rides in the Waymo car in 2016, 2019, 22, 2024. And by the way, the progress in the last 8 years is absolutely amazing. And Waymo has been deploying, if some of you may have taken autonomous cars in Phoenix, San Francisco, and Los Angeles, and they're getting into Austin, right? This is it. So this is, get what, after many tens of billions of dollars, and we're still not there. So just to get you an example, this is transportation, right? Transportation, there are at least close to 1.2 billion vehicles on the road worldwide. Just in last year, there were 92.4 million vehicles sold. And guess what the biggest market is? Asia and Pacific, 51% population. And those of who come from Asia, see what kind of traffic they have. Now, my claim is that the transportation problem, which has historically been around since, before early 20th century, they have become robots. So cars are not the traditional cars, they're robots, because all the new cars have cameras, other sensors. They all have some kind of computer vision technology coming up there. And the industry is trying to put more and more autonomy. The challenge is fully autonomy is not there. And especially a lot of people have claimed, like Tim Cook, the CEO of Apple, said many years ago, autonomous driving is a moonshot for AI robotics, is a mother of AI problem. You see like this. So you see the videos like this, that someday in our life, all cars will be roboticized with fully sensing, and they'll be moving, and we can all sit down and check our email or watch movies. But here comes the challenge. So this is the reality sinks in. The first self-driving car was demonstrated by Dick Manz in Germany in 1987. He showed that on an empty road, you can put sensors and control to it. Now, in the last decade, the Silicon Valley companies especially promised the moon, right? By 2020, all cars will be fully autonomous. There'll be shared riding. We will own a car. There'll be a network of autonomous cars. But guess what? Now, this is a lesson to learn. In spite of a huge amount of investment and money, it hasn't taken off. So basically, here's 2024. And we see few settings of Waymo running in San Francisco and Los Angeles, but we're nowhere close to autonomous cars. I have a Tesla. We have a level 2+ autonomy. General Motors is Super Cruise. They're doing ADAS, but it's not there. And one challenge that comes up here is, I've worked a lot. If you see these robots are in some nice street, a big chunk of the world lives in a traffic like this. So the question comes out to be, you look at the traffic condition on the left, nice paved road with nice sensing, very nicely mapped, to how a big population of the world lives in like this. So the question comes up, when can autonomous cars come in such situation? So this is the one thing we use a curve, which is very common in at least in highly density part of the world. The challenge for autonomous cars is dealing with pedestrians and bicyclists. They're called vulnerable road users. So this is where computer vision and robotics technology is still not good enough, in spite of the promise. So this is the long tail problem again, that the autonomous driving problem is much harder than we expected. So now nobody's giving prediction of what's going to happen. And especially in couple of my students, we see this is some video we got from India. This is computer vision. This is a student work on my former student, Rohan Chandra, who will be joining a faculty at University of Virginia, that how we can deal with there are no paved roads, this heterogeneous traffic, and doing computer vision in this challenging situation, because this is where we are deploying technology. This is, some success with these kind of videos, but now in this unstructured environment, you can see this. And just to simulate a lot of work, we try to show that you can indeed deal with autonomous driving kind of technology in Indian condition, which is very challenging there. So one of the things we did, since a lot of machine learning is based on data, we worked with a big research group and company in India and a data set called Meteor. So this is showing the challenges of Asian driving, especially Indian driving. You don't see in the Western world, and there's not much work on that how can we do it with this? This is a big data set called Meteor. We released and published it last year. And you can see this, you'll see a lot of challenges of, Indian traffic here, hundreds of gigabytes of data, how people drive. The challenge is, when can we develop robotic technology with this kind of traffic where people don't follow the roads, the road conditions are the best, and all funny situations. Look at this. So this is the kind of thing. So this is again telling you, things are not all that simple. Let me go from consumer robotics to autonomous driving. Let me show another example of construction. I'll show you some of the work we have done and also tell you how much technology potential we have. Whenever there's big construction going around, building or whatever, you see excavators. Just to give you a sense of, excavator global market in 2023 was about $76 billion. And is growing at 5% a year because of the construction boom, right? Throughout the world, construction boom, renovation going around. So one question we started ourselves, can we automate the excavators? Now, we saw warehouses, we saw homes, we saw crowded scenes, we saw autonomous driving. Construction is a different side. Normally, the good thing is when you do construction, you actually isolate it. So there are not too many people around it. But construction sites are messy, dusty. There's a lot of mess around. And a lot of the excavators actually work in mining. I don't know if any of you have been to mining. They could be in a very dangerous condition where a lot of human injuries happen and a lot of human health problems happen. So there's a good reason to automate it. So a few years ago, I started a project with my former student team. We took an excavator like this and we put all the sensing. Remember I told you robot is all about sensing? We put LiDARs, cameras, inclination sensor there. And of course, we did the GPUs and machine learning run it and do it. This is published in Science Robotics. It's got a lot of visibility in the media, actually. So the goal was, can we develop excavator? And it's not just that develop to show 10-second video. We want to deploy it. And my team came with a goal that we should work for 24 hours in a real construction or industrial site. That's the challenge we took here. So again, this is all the components. There's a team of 15 people working for 3 years to just show you a lot of sensing, a lot of computer vision, a lot of planning, a lot of control. Remember, perception, plan, control, a lot of software. So this is a lot of technologies coming together, deep integration. And this was to show you, here's a human operator operating a Caterpillar, which is one of the biggest manufacturers of this robot. This is our autonomous version. Literally some toxic sand doing it. And we were able to show that this is done by sensing and software is getting close to 90% efficiency of an expert human. So this is promising. So, but again, when you work, construction sites are not friendly. And again, a long tail hits us. You could have a dry soil. It could have rained last night. Construction still goes on. You could have big rocks. You could have small rock. You could have rainy weather. So you have to develop a system which can work in all situations. And that, again, brings a lot of challenges. How do you build a robust system? So this was something we demonstrated, a few years ago at a big trade show. We showed a big operation. There was a lot of media coverage that, look, it's working, but there was no human. It's autonomous, right? So it goes and build up thing. It's doing this. It looks at the way to pick up the sand and just transportation of sand. It figures where the truck is. It has to figure the right location and pose it. So this was the first one to show it. But not just doing that, we took in a very toxic soil and literally won't deploy it, not just like a public press show. Literally, you can see on the right-hand side, this is fully autonomous and how it looks at it and totally driven by it. So this is a lot of computer vision and a lot of sensing coming in the picture. And literally, I told you, we had this goal that it should work for 24-hour nonstop. So this excavator, by the way, has been deployed. And there are a few of them deployed. They're being used 24/7, hundreds of thousands of hours. And you start at 12 o'clock at night, and you see the progress, 12 o'clock, 6 a.m., 12 p.m., and 6 p.m. See how things go. So this was trying to show that indeed, we could deploy all the technologies together, and literally we could do it. So this is just one excavator. There's so many tasks in construction which can be automated, and there's a lot of investment going around there. Now, I'll just go towards the end. I want to show you where things are happening. So I'll give you 3 examples of new technologies. This is done by group, something got our attention. There's a nice work came out of Stanford earlier this year, robots for cooking. So this is a lot of learning, a lot of language models put together. And this video went viral, especially in China. It'll show you how you can do cooking. Again, tell you where robotics technology is getting today. This is a long video. You can put the version on the web. But again, you see some tasks we take for granted, and some tasks are easy, some are harder. One is flipping the omelet, right? You still kind of balance and control. It's not easy. Even breaking an egg, right? You may not get it right. But this is, you'll see something happen here, and accidents will occur, right? So this is first concept, at least telling you where technology is today, right? The question is, when can it be a robot? How many of you like to have a robot like this in our home cooking? And everybody's asking the question, when we have a robot like this? Now, this is a proof of the concept video, showing potential. But a lot of companies are putting investment. Recently, there's been a lot of investments in Silicon Valley in this area, combining general model and this, doing it. Now, while we're doing that, of course, the big company like Google DeepMind, who did a lot of AI technology, ChatGPT came up. There's a lot of work on the generative AI, the foundation model robotics. So one of the hottest area right now is taking that good hardware and robotics come here together. So this is just a video from Google DeepMind. This was their robot. They have this Auto RT. There's a lot of work on doing generative AI foundation model for robotics. And this is just in the potential of how a bunch of robots are doing tasks. So this is where, especially in the last 6 to 8 months, there's been incredible amount of venture funding going around, big tech putting big money, and also a lot of academic community working. You can see how much it helps us. So this is an activity of research, and you'll see more and more cool videos and research. And just like Google did Transformer, which is a T in Transformer ChatGPT, they also come with the robotic transformer. Right? So you have the visual language action model, which takes computer vision NLP technology, and literally do robot action. So this is very AI-centric work of doing, you have vision and sensor input, foundation models, and you can do amazing tasks. Of course, again, I want to warn you that while these are good tasks, there are a lot of cases foundation model don't work well, and this is an activity of research. Again, what we learn in many examples, there could be a long tail. But this is just to let you know, there's a lot of excitement. People are trying to figure out as generative AI evolves and robot technology gets better, we will see. So we'll see better answer in the next 2-3 years how we do. The last thing which I want to talk about, which has gained a lot of attention in the last 12 months, is humanoid. So humanoid robot is an old idea. There was amazing work done by Japanese researchers. Honda introduced a robot humanoid in 2003. But just at the conference I was last week, this Chinese company Unity introduced a $16,000 robot. Remember, big robots like Spot cost 100K more, a lot of this. But this suddenly caught everybody's attention that you could have a robot in your home for $16,000 doing like this. So this is just
The past decade has seen humanoid robot makers trying to make their creations more and more like humans. But here in 2024, we seem to be witnessing an odd shift in the dexterity of our bipedal robo-dreams. Put bluntly, robotics companies aren't afraid of getting weird with the contortions of their latest offerings. China-based Unitree Robotics released a new video on Monday, available on YouTube, showing off the new G1, which retails for $16,000. It's just the latest demonstration of a robot maneuvering in entirely unhuman ways to accomplish its goals. The video includes an of getting on its feet, There's also a demonstration of the Unitree robot getting kicked and pushed, presumably to show how well it can balance, even when it meets resistance. But we'd be lying if we said it didn't make us uncomfortable. These are, after all, robots made to look like in our brain. Companies like Boston Dynamics release new videos each year, showing its robots walking, running, and then eventually doing backflips, all in the same way that talented humans might do it. But we seem to be on the cusp of a new era when it comes to robotics. Most robot makers have achieved basic human-style walking and running.
So this capability and the cost. So this is another one of those robots. There are a lot of humanoids coming every week, different parts.
While it seems that another humanoid robot is being released every week, we've yet to see one move as quickly or with as much precision as the model just released by Chinese company AstriBot. The AI-powered humanoid robot space is starting to get almost as crowded as the cereal aisle at your local supermarket. Last month alone, we were treated to two impressive offerings from OpenAI. One, a laundry folding bot from Norwegian collaborators 1X that showed off impressive soft-touch skills, and the other a bot from collaborators Figure that demonstrated truly next-gen natural language reasoning ability. Then this month, Boston Dynamics blew us away with the astounding dexterity embedded in its new Atlas robot, and China's UBTech impressed its soft-touch speaking bot, Walker S, and the list goes on. But today's video, showing off the skills of an AI-powered bot known as AstriBot S1, from a relatively unknown sentient-based subsidiary of Stardust Intelligence called AstriBot, truly gave us the chills. It's fast, it's precise, and it's unlike anything we've seen so far. This humanoid can execute movements with a top speed of 10 meters per second, and handle a payload of 10 kilograms per arm. The fact that its website shows that an adult male falls well short of both of these and other AstriBot metrics shouldn't be cause for alarm at all. That speed, as the video shows, is fast enough to pull a tablecloth out from under a stack of wine glasses without having them come crashing to the ground. But the bot is not only speedy.
Again, you can see lots of videos on YouTube. So, this is really, I tell you, a very interesting time, We are seeing three big things here happening, right? One is that we are seeing this hardware. Like, I could not 10 years ago imagine a robot like this, let alone $16,000. So we're seeing a huge amount of progress. And as more companies come in, more investment goes in, hardware is going to get better and cheaper, number one. Number two, we are seeing all the amazing stuff of machine learning and generative AI. And you see all the investments of generative AI, there's so much money going in there. People are transitioning those ideas to robotics. So clearly, this AI-driven method, sensing and thinking here. So that raises a question, as I said, the dream people have had, robots have been used for very specialized tasks in special environment. But will the combination of good hardware and cheap hardware and generative AI lead to general purpose autonomy? So I leave that with a question mark. And again, I want to be very careful because the lesson of autonomous driving has told us some problems are harder than we thought. Even after spending so much money, we could not do it. So I will leave that with a question mark, we do it. But while this happens, let me mention a couple to you. So I covered a lot of things in my talk. Warehouse robotics is already big time. Amazon is deploying 800,000 robots. Companies are doing it. Amazon introduced a consumer robotics product. There are rumors Apple may be doing it. We don't know the details. Robot delivery, you're seeing examples in restaurants, on college campuses, surveillance, and even autonomous driving. We've seen some form of autonomy by Waymo in LA, San Francisco, but leave that aside. General Motors people have told me they have ADAS, driver assistant. That is kind of robotic technology into the car, already $100 million business. And then there's robot construction. So each of this industry, like transportation, which is a $3 or $4 trillion market, is becoming a robotic market. Robot construction, we have just few things like excavation. So just think of this way, any one of these applications is hundreds of billions to trillions of dollars of market. So this is literally how much of this markets can be automated. Now, I'm not claiming we'll have fully autonomous cars in K years. I don't want to make the mistakes that people have done. But at the same time, even Amazon has shown they've recovered. They've done partial automation of warehouse. You can do partial automation of construction. You can do partial automation of agriculture and product produce. clearly that is going to happen. So you're going to see, while fully autonomy will not happen, you're going to see a huge impact in some of this industry. And there's also medical industry. There are many more industries which I haven't covered, but there's no doubt in my mind that you're going to see bigger impact of robotics in many of these applications. So I think I'll just stop here, just to let you know, one of the challenges I will tell you robotics hard is explainability. So one of the holy problem in machine learning is we report good results, we report good cases, report failure cases, we don't know when it fails. So this is what happened in autonomous driving. When autonomous driving happened, there was an Uber accident. Any Tesla accident becomes a national news because there are corner cases where Tesla sensing or computer vision did not work well. So one of the challenges that we are facing in this field is that explainability of AI is still a very hard problem. And one other lesson we are learning is a robot is an example of physical AI. And unfortunately, in the physical eye, the cost of failure is very hard. That one Tesla accident becomes a national news. So on one hand, the problems are hard. At the same time, because the physical world, the expectations are so high. So that is why I just put together this book with my collaborators, that this is still a hard problem, that how do we build explainable interpreter system for robotics, given the expectations, especially this thing. So you got to be careful. There's a lot of potential in AI robotics technology, but at the same time, there are some very challenging open questions. So if you use it for some application, you better be careful and don't overpromise. This is something I want to be very careful in giving my message today. So I'll just stop here. I just at least let you know some of the work I had shown from Chapel Hill in Maryland is given by the sponsors. I want to acknowledge the sponsors we have done. But there's a huge community, as I said, the ICRA, the robotics conference I just went to last week. I've been going there for 30 years. I've never seen such a big conference and so much excitement. And literally that excitement, the potential is coming from what I call AI advances. So we're going to see some great thing in the near future. But at the same time, let's also acknowledge the big challenges that we have to solve. So I think I'll stop here and take any question or feedback from the audience or anybody else. Thank you very much again for putting up for an hour with me. Thank you again.
Thank you, Professor Manocha. We have quite a few questions. Some are interesting. I'll start with one by Nimal Valipuram. He says, is the industry waiting for a breakthrough technology, or do we already have all the building blocks that we need to have a fully autonomous robot someday? Is it just a matter of time?
So this is, as I said, this is a hard question to answer. Of course, I'm a researcher and optimistic, right? But see, how do you define the word fully autonomous, right? And I give you an example. If you follow the media attention about 8-9 years ago, the Silicon Valley companies were promising a fully autonomous car. They thought all Uber will be automated by 2020, right? There was all these exaggerations. And then we found it didn't happen. So, I don't want to will fully autonomous robots fully happen and will work well all the situations, I don't want to make the mistake autonomous cars have done. I would say we have partial autonomy working and autonomy in context that is working. That is already there and that's going to get better. Whether it's fully autonomous or not, it still depends on the application. And remember, this AI technology also have some limitations, especially in autonomous cars. We have seen many examples where the long tail has hit us. So giving promise of full autonomy are still too hard. So let's do more research and we may have a better answer in 3 to 5 years.
Sure. Thank you. There's another question by an anonymous attendee. They are saying, hi, thanks for your talk. I'm a mentor of a robotics team, and I was wondering, what would you recommend for people to get proficient in robotics if you already have a good understanding of mechanics?
So robotics, traditionally, if robotics is a very interdisciplinary field, a lot of, especially in robotics, especially in Asian countries, a lot of robotics happen in departments like mechanical engineering or electrical engineering. It was very hardware and mechanical oriented. But now robotics has such become a field. In fact, I'll tell you what is happening in many places, even in our Maryland and other places. We used to have traditional departments of computer science, electrical engineering, mechanical engineering. Many schools have been doing robotics PhDs for the last 30 years, but there are many universities like, University of Michigan, WPI, and other places, they now have a whole department of robotics. Robotics is as big a field just like electrical engineering and mechanical engineering. And you can have an undergraduate degree. So, you can go and get a degree, a bachelor's degree in robotics, because robotics by nature is very interdisciplinary. You got to learn the dynamics, you got to learn the control, you got to learn the geometry, you got to learn computer vision, you got to learn mechanics. So robotics in some way is one of the most interdisciplinary field. And literally, as I told you, it's more than perception and learning because you have to combine and make them work. So that's what makes the field exciting. But if you really want to get proficiency in robotics, it's just like proficiency in electrical engineering, computer science, you got to take a whole bunch of courses and learn that. Now, what some people do is they specialize. Like, okay, my own research is more computer science oriented. I do more algorithms or planning or AI. But there are other people working on new materials, soft materials, or new controllers. So it's a very interdisciplinary field, and depending on your interests, you may specialize in some of that.
Okay, great. Thank you. There's another question by Arjun Saxena. He says the original predictions for autonomous driving and when Waymo, etc., will become mainstream turned out to be too optimistic. What is your view on the current path? How many more years do you think it will take to get there?
Boy, I really can't answer that question because any prediction I give, more like is going to be wrong, right? So this is, as I said, we have learned the lessons. Sometimes I tell you, when I was a graduate student, I tell the story. I went to Berkeley in 1980s and early 90s. At that time, when I entered the graduate school, AI and robotics was very hot. By the time I graduated, there was a dark winter of AI and robotics, and people thought they were overhyped. And then nobody bothered. And then machine learning came. So I always joke, I'm pretty old now, but the hype sometimes does it. So, I don't want to give any number. All I'm saying is that we are seeing some kind of these robotic technologies like perception cameras and some kind of autopilot are coming in the cars. So they're still not fully autonomous, but somebody said they're like level 2+, or people are building level 3 autonomy. So we're going to see more and more autonomy in the cars. And, and they have still huge market in terms of ADAS. ADAS stands for driver assistance. So they can improve our safety. Like when I drive Tesla, sometimes my Tesla is telling me that, hey, you're crossing the lane. I said, thank you. I'm getting old. So at least partial autonomy is working, is going to get better. I don't know anybody today can make even a prediction that by year full autonomy, level 4, level 5 will come, because especially you might work on highways. Highways are easier. What happens if you come on the street? If you ever drive on a college campus, it's much harder. And what happens when you go to Asia? I show you a whole bunch of traffic situation where people are so crowded, people don't follow rules. So there is level of autonomy and there's level of conditions. So I think people working in this area are going to be working this problem for a long time.
Okay, great. Thank you. There's another question by Professor Omkar Krishnan. He says, excellent webinar. Want to know whether replacement of BPO and KPO by robotics is possible beyond chatbots.
I didn't get the question. Replacement of what?
BPO and KPO, I think business process outsourcing and knowledge process outsourcing, if I'm not mistaken.
I don't fully understand what BPO means, but my answer is, again, it's very hard to, there are all the predictions about robot replacing human jobs, I don't see that, there's even all the generative AI LLMs, right? There's all this talk about AGI, artificial intelligence, and a lot of people tell you they're a little bit more hype, right? So now I give you an example of warehouses. Amazon is deploying more than 700,000 robots, many more, a lot of warehouses being automated because there are things they could do, like moving boxes around, and they made it friendly there. But even in warehouses, this, as I said, one of the biggest challenges Amazon deal with is when they get 2 items, let's say you get an iPhone cable and a chocolate, and they want to put that in a box and ship it, right? How do you put them in the box? How do you place them? How do you put the buffer material and tape it up? Still, a lot of the tasks are human. So even warehouses, the robotics has huge success. How much of warehouse is fully automated? And it's a long way to go. So I don't really see, based on all the things I've done, that fully autonomous in any market sector is not an easy problem. So it's not that easy. That's all I can say. So it's very hard to make a prediction that in any market sector when fully autonomy will come. I'm not sure. I can't predict that.
Thank you. There's one more question. So what we have during these webinars is that many of our alumni also invite their families, especially their student children, who may join. And so one of the questions here by an attendee is, what would you recommend for a student who wants to specialize in robotics and AI? How should they proceed?
Well, so, this is, in fact, I'll just tell you right now, I'm in Washington, D.C. area. The amount of excitement, there's high school, I see some really amazing high school kids. But every spring, I get more than 100 inquiries for people who want to come and work in my lab. And my apologies that I don't have capacity to absorb them. From what I'm seeing, and even in computer science AI, like in Maryland, we have a very big major, a computer science major. We are close to 3,500 to 4,000 students. And, the demand is very high. So the amount of student interest from high schools to undergraduate degree to graduate degree, AI robotics I've never seen so much excitement and interest in my 35 year academic life. So that's what creates an excitement, which of course is good. There are a lot of people interested, but I would always say is, have your strong foundations, mathematical foundations are like if you want to robotics, basic physics, dynamics, control. And if you want to learn machine learning, I say get the basics of, statistics, like a big data. So foundations are always, as an academic, foundations are foundations. You fundamentals learn. Build strong foundations in math, physics, control theory, and all the stuff, and sensing. And of course, you can take advanced courses after that. But as an academic, I still teach foundations, foundation, because ultimately today we are seeing some success of machine learning, but at the same time, we are limitation of machine learning. Machine learning is not, the long tail problem. So I'm hoping some of these young kids who have strong foundation may come with something totally new tomorrow, which we are not thinking of today. So there's still a lot of room for innovation, and I would expect the next generation is going to come with innovation. So they should have a broader view, and there's still a lot of great science to be done in this area.
Great, thank you. There's one more question by Rakesh Jha. He says, thanks a lot for the amazing and broad talk. Is there an AI alternative or meaningful enhancement to SLAM algorithms, particularly foundational models in crowded environments, for example, in occupied buildings?
So SLAM is, if I understand correctly, SLAM is a very classic topic we teach, localization and mapping. So there's a general perception of SLAM is a very well-studied problem. But one thing I would say, and this is based on my work with Amazon. So Amazon, this robot called Astro, which is a consumer robot. Actually, even if you look at the video and I played with it, Astro does a pretty good job of SLAM in your home. So SLAM is one place where we have seen not only great academic research, but we see lots of industrial products. So I think at least in indoor scenes, we are seeing some reasonably good SLAM solutions. So at least that is something, definitely the progress has been very good thanks to computer vision and other sensing. So we have definitely seen a lot of amazing progress in SLAM that is even consumer robot products. So.
Thank you. There's one other interesting question, challenging you to predict again. This one says, do you think we will see more robots in space than on Earth?
Well, clearly, if you see NASA has done some amazing video. There were a lot of great work done by NASA, and there was a group at Carnegie Mellon, which is one of the top robotics university. They built Mars rover. So we have clearly seen, robots being sent to the Mars. In fact, I've seen some calls from NASA because they asked the question, could you develop robots that could go and surface of Mars? We don't have full information. The gravity is different, and the terrain is different. Maybe it's not as hard or soft. They may not have water. So there's one challenge people are working on. Can we develop robots which can go and traverse the surface of Moon or the Mars, So there's definitely research in that. Now, what's the future of space? That's a whole different talk, right? That's not really my expertise, right? There are a lot of big companies investing in space, but at the moment, all I can say is there's a whole branch of people. There's a lot of work on space robotics, which I did not cover in my talk. There's a lot of robotic stuff lot of amazing stuff has been done by NASA that people on space robotics did not cover. And clearly, you will see definitely a lot of application of robotics to space exploration. There's no doubt about that.
Thank you. This is a question by Ravi Sitapati. He says, what are some of the cybersecurity issues with robots? Any work being done there?
Yeah, so that's an excellent question and a very important question. For example, I tell you, let's say consumer robot, like you already have devices at home, right? We all keep devices like Alexa or consumer Google Home, right? Or even your smartphones, right? They have cameras and they have microphones. So they are listening to all your conversations and listening to you and watching your videos. And if a robot like Astro, which is selling at home, right? Here's a robot walking in your bedroom, in your living room, right? So that leads to all kinds of questions. In fact, one of the challenges they face is that because it's in your home, they have to process it on the robot. We call edge computing. They cannot send your data to the cloud. Imagine your data go to the cloud on the network, which is not secure, and your privacy is being invaded. So as these robot devices come to our daily life, there are some very serious privacy concerns, right? The robot's collecting your data. My Tesla is collecting my driving data. My Tesla could be listening to my conversation in my car. You saw surveillance robots, right, in the malls. So clearly there are some very serious privacy and security issues that we have to tackle, just like as robots come to our daily life, these robots consist a lot of sensing, which is collecting a lot of data. So we have to make sure that we totally be compliant with all the private security issues. And there are a lot of researchers working on that. But I do want to acknowledge that the use of robot and sensors give rise to new kinds of privacy and security problems. There's no doubt about that.
Thank you. I think we are almost out of time. I'll take one last question and then we will close it. This one is by Prabhat Kumar. Says, Professor Manocha, will you touch upon the role of high-performing cellular networks, 5G, 6G, in further improving productivity, security, and surveillance through AI-driven robots, autonomous guided vehicles, etc., in multiple verticals, manufacturing, supply chain, healthcare, ports, airports, etc., etc.
No, so a lot of technology advancement, like anything like 5G, 6G, which is going to provide like high connectivity, high bandwidth, and low latency, and will be helped. Because as I told you, one thing, if you look at a lot of machine learning, I don't know if you saw the robot I showed you. I give you an example. I was showing some videos of, of a spot robot. So this is an example. This is a robot to build autonomous. This was the place, within a network. So in this robot, we needed a GPU to do the inferencing. It's very computer intensive. And you see here, this is a power supply, a battery, right? So for my robot to do full autonomy capabilities, I need a lot of sensing and a lot of computational power to do it, right? And I'm still not fully autonomous. So if you look at a lot of people, like a lot of people do computer vision, like all the big NVIDIA data center, they do on a cloud. So clearly, if my robot has very high bandwidth access and low latency, clearly, we can do a lot of this AI computation on the cloud. That definitely help a lot, right? So of course, all those high bandwidth and high connectivity and low latency will help every field, including robots, no doubt about that. Because these computations that we're seeing, this computer vision and inferencing and learning is computer intensive. So we need a lot of support. But that also gives the rise to issue which I was telling you about, like home robots, right? Would you feel if the robot in your home and sending your videos and your conversation to the cloud? Because that leads to all kind of private security issues. So we need better technology, and just like sensing and other things and data, high connectivity and high bandwidth has a big role in robotics too. There's no doubt about that.
Great. Thank you, Professor Manocha. We are out of time. I greatly appreciate such a wonderful, insightful talk that you delivered. You covered the history of robotics. You gave us a preview of the advancements in robotics. You highlighted some of the challenges that may translate into some of the opportunities that may surface from this discussion for people. For the audience, thank you for your interest in this series of AI seminars or webinars. We will have more sessions, not only by academics, but also by practitioners, innovators, investors, and more. So please stay tuned. Thank you again, Professor Manocha, and thank you everyone for joining.
Thanks for giving me the chance, and it's always fun to talk to PanIIT community. That's my home. So thank you everybody to PanIIT for everything they've done for us.
Thank you.